I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about octal to binary number conversion as well as binary to octal number conversion. It is very easy and it is very simple to convert from octal to binary and similar from binary to octal. Sometimes to convert decimal number into equivalent binary number, first we convert it into octal, because while converting into binary for larger number, it is a long process. We have to repeatedly divide by 2 for longer steps. But to convert in octal, it is a very short process. In 3 or 4 steps, we can convert any decimal number into equivalent octal number. And then from octal to we convert it into binary. So that is very simple process. So let us start now how to convert octal to binary and binary to octal. Let us study about first about comparing octal and binary number. In binary number, we know that we have only 2 bits, that is 0 and 1. And for binary, base is 2. And binary base can be written as, that is 2 raised to 1. When we give power 1, there is no change in the value. So 2 raised to 1, that is 2. So for binary number, base is 2 raised to 1. Similar way, in octal number, we have total 8 bits and base for octal, that is 8. And base for octal can be written as 2 raised to power 3. That is 2 multiplied by 2 multiplied by 2. So 2 to the 4, 4 to the 8. So base can be written as 2 raised to 3. That is just written for the sake of comparison. Say here we can compare that for base for binary it is 2 raised to 1 and for base octal that is 2 raised to 3. So the difference is 3. Octal base is heavier than binary by 3. So 3 is a number you should always remember while converting from octal to binary and binary to octal, because when we convert octal number into equivalent binary, we take a grouping of 3 binary numbers, right? So this is very important, but while converting you will come to know that how it can be done. Now decimal and octal comparison. We know that in decimal we have total 10 digits, 0 to 9. In octal number we have only 8 digits and that is 0 to 7. So if we compare decimal number with equivalent octal number, then we should know that 0 to 7 it is almost similar. So 0 to 7 it is similar, but up to single digit in octal we can go up to 7 only. But if we want to go beyond a value of 7, then we should go for 2-digit value. So suppose for decimal number 8, if we want to write equivalent octal number, then we have to write like 1 0. Same way for 9 it is 1 1, and we can go up to 1 7 for decimal number 15. But once we reach to 1 7, then we have to go for 2 0. Then again 2 1, 2 2, 2 7. When we reach to 2 7, then we have to write 3 0. Something like this. Decimal to binary. And this number system is known as 4 to 1. This grouping of 3 is very important while converting octal number into binary and binary to octal. So decimal value 0 an equivalent binary number, that is 000, right? See, you should always remember this 4 to 1. 4 to 1 is very important, right? And we have to do the addition. 4 plus 2, that is 6. 6 plus 1, that is 7. So if we write 111, then maximum value for 3 bit we can go for 7. And in octal number we know that maximum value in single digit possible, that is 7. So 111, that is 7. And same way we have different combination of binary number equivalent to decimal number, right? But 4 to 1 is very important. Suppose we take a 5, then 101, and then it is 4 plus 1, that is 5. For 6, that is 110, meaning this 4 plus 2, that is 6, right? Similar way, we should always remember this. You have to remember from 0 to 7, because while converting from octal to binary and binary to octal, this 4 to 1 system will be very much helpful and we will have to use very frequently. Now let us go for conversion. We start with octal to binary. Suppose we take any octal number, that is 645. Suppose. One thing you should always remember, that in octal we have maximum digit value possible, that is 7. Beyond 7 there should not be any number in octal system. So 645. Now it is very simple that we write the individual number of the octal number 645. For each individual number we have to convert into binary number in group of 3. And why we need to convert it into group of 3, that I have cleared at the beginning of the lecture. Because 2 raised to 1, that is base for binary, and 2 raised to 3, that is base for octal. So octal is 3 times heavier than binary. So we have to do the grouping of 3. Suppose for 5, if we write equivalent binary number, then we know we can write as a 101. You should always remember 4 to 1 system. So 4 plus 1, that is 5. For 4, equivalent binary number, that is 100. For 6, it is 110. So after writing equivalent binary number for individual number of the octal, now we have to club it. So 645, that is octal number, and it can be written in equivalent binary, that is 110, 100, 101. We have different values 110, 100 and 101, and in similar fashion we have to write equivalent binary number. So it is very simple, and we should know how to convert into binary in group of 3, and that number system is known as 4 to 1. So 4 to 1 you should always remember while converting octal to binary. Let us take one more example. Suppose we take 134. So we write 134. Then we convert into equivalent binary in group of 3. So 4 we know that it is 100. For 3 we know that it is a 011. And for 1 we know that it is 001. Now we have to club. So equivalent value of binary for octal number 134, that is 001, 011 and 100. But one thing you should be clear, that 0 in the most significant bit, they are useless. In least significant bit, zeros are very important. But in most significant bits, zeros, there is no value or no significance of zeros. So this 20, 2 times we have 001, so 00, that can be omitted, right? So for the sake of simplicity, we can write 134 octal number, equivalent binary number, as a 101100. We cannot omit 0 from the least significant side. From the right side, we cannot omit. On the left side, if we have additional zeros, that can be omitted. Let us one more example of fractional number or mixed number. So we have taken 345.64. This is a mixed number. We have integer values as well as we have fractional values. So there is no difference if it is a fractional value or if it is a integer value. So now same way we write 345, that is our integer value, and we have 64, that is our fractional value. Now we need to convert each individual octal number into binary number in group of 3. So 5, we know that it is a 101, 4, that is 100, 3, that is a 011, and same way for the fractional number 6, that is a 110, and 4, again we know that it is 100, right? So now conversion is complete and we have to club. We should always remember that where we need to put our fractional point. So for 345.64, we have equivalent binary number, that is 0, 11, 100, 101, and now we have a point. So it comes to 110 and 100. See, now one thing should be clear, that in the integer value, most significant bit zeros are not significant anymore, right? We can omit these zeros. In similar way, after a point in fractional values, at the least significant side, zeros are not again has any significance. So we can omit these zeros also, right? So we can write again 345.64 as a 111, 00, 101.1101. We have omitted 2 zeros from the fractional side and we have omitted 1 zero from the integer side. So this way we can convert our octal number into binary number. It is very simple, very easy, and you can do on your own this conversion very easily, right? Only you should know or you should remember that how to convert into equivalent binary number, each individual number, how it can be converted into binary number in a group of 3, and we know that it is 4 to 1. So 4 to 1 is very important while converting octal to binary as well as from binary to octal. Now let us see how binary number can be converted into octal number. So let us start binary to octal. Now we have taken one binary number, that is 101, 101, and it is a 6-bit. Now while converting from binary to octal, again we have to make a group of 3 binary bit, right? It is compulsory to prepare a group of 3 binary bit, right? If we have short of bits, then we have to add additional zeros, right? But that we will see when during that type of example. In this case, we have 101, 101. So we have total 6 bit. So 2 group of 3 bit can be possible. We start from the least significant bit, that is from the extreme right position. So 101, that is first group, another group, that is again 101. Now for each individual group of binary bit, we have to write equivalent decimal value, equivalent decimal value, right? So for 101, we know that we should always remember 4 to 1 system, right? 4 to 1 binary system. So here we have 101. So meaning is 4 plus 0 plus 1. So 4 plus 0 plus 1, that is 5. 101, we have taken one group. Second group, that is 101. We have separated two groups. And now we need to convert from group of 3 binary bit into equivalent decimal number. So 101, as I said, that is 4 plus 0 plus 1, that is 5. Same way 101 again, so it is 5. So now it is simple. So binary number 101, 101 and equivalent octal number, we have to club this both the number. So 55, that is equivalent octal number. Very easy and very simple. But you should always remember that we have to compulsory prepare a group of 3 binary bit, and from the each 3 individual binary group we have to convert into equivalent decimal number. And maximum possibility in group of 3, that is 7. So if we have a number 111, then it is 4 plus 2 plus 1. So maximum possibility of the number equivalent decimal number, that is 7. We cannot go beyond a 7 while we are in the group of 3. Let us take one more example. Suppose we take 10011. See, now you can observe that we have only 5 bit in the given binary number and we require total 6 bit to prepare a group of 3, right? So we have one group, we have 011. At this, we start from the least significant bit from the right side. So first group we have prepared, that is 011. But in the another group, that is 10, we are having only 2 bit. So what we need to do is we need to add additional 0 on the left side. On the left side, at the most significant side, if we add 0, if we remove 0, there is no change in the value. So we need to add 10. This one group is ready. In another group, we have only 2 bit. So 10 we have to add 010, right? It is compulsory to prepare a group of 3. And we have now second group of 3 binary bit is ready. So now first group, that is 011, second group, that is 010. And now from the individual group of 3 binary bit, we have to convert into equivalent decimal number. And that is very simple. 011, we always remember 4 to 1 system. So 0 plus 2 plus 1, so 3. Here we have 0 plus 2 plus 0, so 2. So now octal number is ready. So for 10011, we have equivalent octal number, that is 23. Very simple. Let us take one more mixed number, integer value as well as fractional value, right? So we write in group of 3. Here we can observe that from the radix point or from the fractional point, for the integer number, we proceed from right to left while preparing group of 3. On the fractional side, we proceed from left to right, right? So here we started making group 011, 101 and 11. So in integer values, we have 2 ready groups of 3. In the next group, on the most significant side, we have only 1. So we are short of 1 bit, right? So we have to add 10 at this stage. Similar way, in the fractional number, we have started making a group from the left to right, right? So one group we have prepared, that is 101, and In the next group, that is 0, 1, we are having only 2 bit. So again we are short of 1 bit, right? So we have to add one more 0 at this stage, right? In the fractional value, we can add zeros at the last, while in integer value, we can add zeros at the beginning on the most significant side, on the left extreme side, while in the fractional value, we can add on the right extreme condition. So we add one 0 and we add another 0, and now our groups are ready for integer values as well as for the fractional values, right? Now we write individual binary group of 3 bit, that is 0, 1, 0. Then we have 1, 0, 1, and same way for the integer value, that is 0, 1, 1, 1, 0, 1, 0, 1, 1. Now next step is very simple. We have to convert into equivalent decimal value, right? So 0, 1, 1, that is, we should always remember 4 to 1 system. So 0 plus 2 plus 1, so it is 3. 1, 0, 1, that is 5. 0, 1, 1, again it is 3. 1, 0, 1, that is again 5. And 0, 1, 0, that is 2. So now we have octal number ready. We know that where to put our fractional point. So 353.52, that is our equivalent octal number, right? So it is a very simple, very easy to convert either from octal to binary or binary to octal. But before you try, you should always ready with binary values, that is 4 to 1. So from 0 to 7 in decimal, equivalent binary number should be at heart. You should always remember equivalent binary values, so then you can do this conversion very easily and fast. So thank you for watching my video. Keep watching, and if you like, subscribe my channel. Thank you very much.